once you identify the critical sub-problems or sub-functions of the product that you are developing, then you can look at the implementation of these sub-functions. Then you can generate some ideas or concepts to implement those sub-problems or sub-functions. Now for that, one way of doing it is you can look for external resources. You can gather some more information from the customers or certain experts outside to the project team. You can talk to lead users. Lead users, as I said earlier, are the set of users who do not happy about the existing products. They always look for improvements. So you can collect some valuable information from them about the possible improvements. You can consult experts like technical experts, salespeople, experienced customers, the engineers, etc. To get their ideas or information. And then you can look at what people have already developed as technology. You can look at patents, the related inventions by others. And you can also look at the literature, the research publications and books where people have reported various new technologies in implementing certain things. And also you can get some ideas from your benchmark analysis about the existing products, and accordingly you can look for possible ways of implementing certain sub-functions based on how others have addressed those issues. And then again you can discuss among yourself, share your experience and knowledge and expertise in coming up with some new ideas. For that, of course, you could use brainstorming or brainwriting techniques. I have explained these techniques earlier. And one method is, of course, you could ask each member to come up with at least 10 solutions for each sub function, and then you can get together and come to an agreement about what are the best ideas. Then you can sit together and analyze these different ideas coming from different members and come to an agreement about promising ideas to study further in this analytical process. And some hints, some tips for generating solution concepts. Always make analogies, that is how others have solved these similar issues. And you can create your own wish list and your own dreams, and you can discuss and decide how these wishes can be implemented. And you can generate ideas through distort ideas. So when you have an idea, you can distort it, you can change it as you wish and see whether you can generate new ideas. And you could use related stimuli, that is you could start from somebody's idea. So when someone proposes an idea, you can consider it as a basis and then improve on that basis. Or you can use unrelated stimuli, that is where when you feel like you're not getting any ideas, when you feel like you're bored, then you take a break and come back and look at the problem again. And or you, as a team, you can set quantitative goals, like each member need to bring up 10 ideas. And also you could use something called gallery method, that is people brings up different ideas and you get together, discuss and merge different ideas and develop better ideas. So you could use these methods as tips to generate ideas to implement sub functions that you're looking at. So this is an example for the nailer. So these are some of the ideas that have come up with regard to storing and accepted energy. And this is some ideas. These are some of the ideas for applying translational energy to the nail. So you can go through this. So you can go through this and get an idea about how they have expanded their spectrum of generating different ideas. Now, once you have agreed on the functional decomposition, identify different functions and related technologies or ways of implementing these different sub-functions, that is generating ideas or new concepts for implementing different ideas. Then you can explore systematically to see what combination of ideas would make a better product. So there are several tools available for this. Concept classification tree, that is a kind of a tool that we could use to divide the possible solutions into independent categories. I'll show you with an example. And there's another tool called concept combination table that helps us to selectively consider combination of fragments or combination of different sub-functions. And there's another tool called morphological chart and concept mapping. So you could use these techniques to decide on what concepts you could consider in implementing these sub-functions. Now, if you look back, the functional decomposition of the nailer problem, once you identify the critical sub-functions, in this particular example, sub-functions related to energy. If I take, for example, store and accept external energy, then you can represent using a classification tree as you could see here. You represent different techniques that you could use for store and accept energy in a tree diagram like this. For example, you can store energy chemically, and you can use energy in the form of compressed air, pneumatics we say, and in the form of hydraulics, complex oils, in electrical means, or nuclear, or many options that you can consider. And similarly, to store and accept chemical energy, you could use, for chemical, for example, there can be several techniques like fuel air systems and explosive systems. For example, electrical, if you choose electrical, then there can be just, you can plug it into the wall socket, or you can use a battery, or you can use fuel cells. Like that, you can expand this tree based on the ideas or based on the options that you have to implement these different options. And once you construct this technique, once you construct this tree, then you can look at the tree and make certain decisions. For example, if you identify certain options as less promising options or less promising branches, then you can prune them. For example, a handheld nailing machine, for example, the nuclear is of course cannot be used, so you can simply cut it off and you don't have to look further in that direction. And then you can identify these branches as independent approaches to solve the problem. For example, one path is a completely independent path to other paths, so it's a unique approach. Then by looking at this, you can understand whether each and every path is explored enough. That is, for example, if you look at the pneumatic option, which is a promising option for handheld tools, as of now it is not explored enough. So you could, when you look at this, you can think you can further explore this for further improvements. And then again, you can understand certain things. The refinement or the decomposition is not enough. For example, if the energy uh, required for nailing is too much to give it using a battery, then you could think about energy storage device within the system, like a flywheel or something like that. So those information you can gather once you construct the tree. By looking at the tree, you will be able to recognize these important aspects. Once you complete the construction of the classification tree, then you can think about different technologies that you could consider in implementing these different sub problems. For that, of course, you could use combination tables. In the combination table, in the very first row, we represent the sub problems in different columns. Now, in this particular problem, we have identified three different sub problems for each category. We have three categories initially for uh, functional decomposition, that is material flow, energy flow, and the signal flow. For each category, we have identified, or we divided each category into three sub problems. Each of these sub problems are indicated in the first row, as you can see here, and in these associated columns we write down the different technologies that we could use to implement this sub problem. For example, to accumulate energy, you can use spring, you can use moving mass, like that. So once you complete identifying different technologies to implement different sub problems, then you can now the different technologies that we could use to implement these sub problems are basically identified during our external and internal search, and we call these are solution fragments. The technologies, different technologies, are called solution fragments. Once you identify all fragments, then you can combine uh, the technologies or the fragments in each column, as you can see here, to find a solution to represent that category of subproblem. Now, identifying one particular combination is not enough at all to make the final conclusion. So you have to look at different combinations to see what is the best. But again, if you look at, for example, if you look at this problem, you have four fragments in the first column, two in the second, and three in the third. Accordingly, you can generate 24 different combinations. So if you want to combine, if you want to consider all these combinations, of course it will be very time consuming process. If the number of columns in the combination table is more than 3 or 4, then that means there will be too many combinations that we could consider. Accordingly, it will be very time consuming process if you were to consider all the possible combinations. Therefore, this combination table technique will become very ineffective if there are more than 3 or 4 columns. Therefore, it is very important during functional decomposition to consider only 3 to 4 subproblems for each category. Otherwise, the solution will not be feasible practically due to large number of possible combinations. As I said earlier, each combination provides you a concept for your problem solving, and one combination is solenoid spring and multiple impact. So you can think about a solution, how we could combine these three options and provide a solution technically. And one other combination would be rotary mass with transmission, spring, and single impact. So for that also you can create some technological solutions, practical ways of implementing this, and there can be more than one way of implementing one combination, as you can see here. And of course, you can consider all these different combinations and see with your technical knowledge, you can evaluate what combination would be the best combination for the implementation of a particular idea. Now, one other technique that we could use for the same purpose is morphological chart, where this morphology refers to the study of the form and the structure of the solution space. Accordingly, morphological charts can be used to generate ideas about new design concepts. Usually, these morphological charts are constructed through brainstorming, and this will help us to understand different possible options that you can consider, and different combinations also can be identified using morphological charts. For example, these are the concepts, possible concepts, possible technological solutions, and these are the sub functions that we identified, sub problems. And you can, for each sub problem, you can work out, you can identify different concepts that you can use. And of course, again, you need to have certain engineering knowledge to do this. As a complete solution to the problem, you can combine different concepts, as you can see here. So you can consider several, you can generate several possible solutions for the problem by combining, by considering different combinations, as in the case of combination table just we discussed a while ago. So this is another example, the morphological chart for development of design of a chair. So you have different functions, seat material, number of legs, etc. And the options, you can see different possible options. And once you construct the morphological chart, then of course this can be represented in a concept map, where you can understand the connectivity of different options that you considered in the final design. And once you obtain several different concepts initially for further consideration, then of course, as usual, we'll have to go back and revisit all these things carefully and make sure that you have considered all specifications, all customer needs in the development of concepts. And you could again go back and get a feedback from the lead users and other special and important customers, make the necessary refinements of the concepts to further develop the solution. Now, before winding up, just want to mention about some reasons for major product failures, so that you can be aware of these things when you work on your problems. One major reason is non-consideration of adequate alternatives. That is, in groups there can be some dominant members, so they try to convince others that one or two solutions they propose are the best. Accordingly, you stuck with a couple of solutions which are not adequate. Lack of benchmarking is also a reason for major product failures. Of course, as I mentioned earlier, you have to thoroughly investigate about the existing solutions before proposing your own solution. Therefore, you have to make sure that you explore the possible solutions that people have already provided in related problems. In addition, if you could recall one of our previous exercises, the reverse engineering activity that we worked out. Of course, the reverse engineering is a very effective tool that we could use to understand the existing products particularly the technological implementation in existing products. So you could use reverse engineering to study further unselected existing products during this benchmarking. Lack of team effort is also a major reason for product failure. Therefore, you have to make sure that all team members contribute to the development of the product. In addition to that, there can be uh, issues like ineffective integration of promising partial solutions and failure to consider entire categories of solutions. So that is mostly you have not considered all combinations, all possible options adequately in the development of the product. In summary, we start this exercise of product development with some needs, and then we apply quality function deployment on the needs to understand the problem, and then create the specifications of the problem, that is that describes the functionality of the product that you are developing, and then you perform functional decomposition, morphological analysis, etc. And then you do a lot of brainstorming, get the help of experts, and look for patents, refer books, journals, etc. to generate different ideas, and develop various concepts, different concepts for the problem. And then after that, of course, you could use concept selection methods to get the final concept, which will be discussed later. And of course, usually once you identify your requirements, that is specifications, you do a design review, that is the quality function deployment that we'll be doing just before generating the idea, as I explained at the beginning of this lecture. And then again, once the final concept is developed, identified, then again you'll have to make a review to see whether everything is in order. So so these are the references. This is usual references, and in addition to that, I have added one more reference, the last one. And of course, as the next task, I have listed several activities which we will be doing in the coming weeks. So you have to do the quality function deployment to understand the entire problem and see whether you have your specifications have addressed the needs adequately. And then you'll have to do the functional decomposition to decompose your problem into sub problems. Please make sure that you do not divide it into many divide your problem into many sub problems. As I said earlier, if you have many sub problems, then there can be many combinations in the combination table, which makes it very difficult to practically observe all possible combinations and then find a solution given within the given time frame. And then you could once you complete the functional decomposition, then you can construct the classification tree for each sub problem, and then obtain different concepts by combining different technological options that you have using combination table. And then at least you need to generate at least 5 concepts for the problem that you will be dealing with. These are the tasks for the next few weeks. So we'll further discuss these things, how to incorporate these things into your problems during the next session on Tuesday. Thank you.